Lesson 3, Solving Problems with Factorials. So first, a quick refresher on how to factor. So when you're factoring, you want to find two numbers that add up to your middle term, which is 10, and multiply to get your outside term, which is 24. So we need two numbers that add to 10, multiply to get 24. They should be 6 and 4. When a is 1, which it is, you put it straight into the brackets, x plus 6, x plus 4. For the next one, we have two numbers that add up to make 7 and multiply to get negative 60. Our numbers should be one positive number and one negative number, because this is a positive and this is a negative. So our number should be negative, well, this is a negative 7, negative 12 and positive 5. So we have x minus 12 and x plus 5 is factored notation. For the last one, we have two numbers that add up to make 9 and multiply to get negative 36. Because this is a negative and this is a positive, our two numbers should both be negative, or one should be a positive, one should be a negative, because we need to multiply to get a negative number and multiply or an add to get a positive number. So our number should be negative 3 and positive 12. So it should be x plus 12, x minus 3. It doesn't matter which order you put them in as long as you put them in the brackets. So when we're solving for factorials, we often have a missing number. So we like to call that number n. So if we were to rewrite n plus 2 in factorial notation, we would know n plus 2 would be our first number, and then we'd have n plus 1, and then we'd have n, and then we'd have n minus 1, n minus 2, and dot dot dot, all the way at the end of the road, we'd have 3 times 2 times 1. At some point, it's going to get down to 3 times 2 times 1. So if we were to imagine, let's let n equal 17. The first one would be 17 plus 2. We'd have 17 plus 1, 17, 17 minus 1, 17 minus 2, dot dot dot, all the way to 3 times 2 times 1. So 17 plus 2 is 19, so this is the same as 19, times 18, times 17, times 16, times 15, dot dot dot, all the way to 3 times 2 times 1. So that's why we can rewrite n's like this, because n can be any number. At some point, it has to get to the end at 3 times 2 times 1. So for the first example, we want to simplify n plus 3 times n plus 2 factorial. So if we were to write, so for this one, if we were to simplify this n plus 2 factorial, that would be the same as n plus 2 times n plus 1 times n minus 1, dot dot dot, 3 times 2 times 1. And we still have this n plus 3 in front. So if we look at this, this is the exact same way you would write n plus 3 factorial. So we can rewrite it as n plus 3 factorial, and that is the simplified form. Okay, so for this one we want to rewrite n plus 1, so we have n plus 1 times n minus 1 times n minus 2, dot dot dot, 3 times 2 times 1. So that is how we rewrite n plus 1. And on the bottom we have n minus 1 times n minus 2, dot dot dot, 3 times 2 times 1. So we can cancel out all of this past n. So we're left with n plus 1 times n. And if you wanted, I guess you could write it as 2n plus n. I don't know. So this would be the simplified form for that one. For example 4, we want to solve when n factorial over n minus 2 factorial equals 90, where n is an element of the integers. So we're going to rewrite n factorial as n times n minus 1 times n minus 2, dot dot dot, 3 times 2 times 1, over n minus 2, dot dot dot, 3 times 2 times 1. So this, everything past n minus 2 is going to cancel. So we're left with n times n minus 1 is equal to 9. Then what we're going to do is we're going to distribute this into the brackets. So we have n squared minus n, and we're going to move the 9 to the other side. So we have n squared minus n minus 9 equals 0. So now we're going to factor. So we have two numbers that add up to make -1 and multiply to get -9. Our two numbers will be 90. This is a 90. The two numbers will be -10 and +9. So we have n minus 10 and n plus 9 equals 0. So what we know is to solve this, we know that either n minus 10 equals 0, add 10 to both sides, so n equals 10, or we know that n plus 9 equals 0. So we minus 9 from both sides, and n is equal to -9. Because we can't do the factorial of -9, this will not be a solution. So our answer is n equals 10. So to check, if we had 10 factorial over 10 minus 2 factorial equals to 90, we'd have 10 factorial divided by 8 factorial. 10 factorial is the same as 10 times 9 times 8 factorial over 8 factorial. The 8 factorials will cancel, so we have 10 times 9 equals 90, and 90 does equal 90. So that is our solution. N equals 10.